morning students, welcome to our online video class of chemistry. In previous section, we had discussed about different properties of matter. Today we will discuss about change of states of matter.
Change of states of matter. Can matter change its state? We all know from our observation that water can exist in three states of matter. Water exists as solid in the form of ice, and as liquid in the form of water, and as gas in the form of steam or water vapor. You can observe that water comes as ice out of the freezer of a refrigerator, as water out of a tap, and as steam or water vapor out of a kettle of boiling water. We can change the physical state of matter in two ways: by changing the temperature and by changing the pressure. Let us study now how the temperature affects the change of states of matter. By increasing temperature, that is by heating, a solid can be converted into liquid state, and the liquid can be converted into gaseous state on heating. And by decreasing the temperature, that is by cooling, a gas can be converted into liquid state, and a liquid can be converted into solid state on cooling. For an example, if ice is heated, it changes into water, and if water is heated, it changes to steam, and if steam is cooled, it changes into water, and if water is cooled, it changes into ice. We have studied that if we heat ice, it changes into water. In this case, solid ice changes into liquid water. So, a change of state has taken place. The process in which a solid substance changes into liquid on heating is called melting or fusion. And the temperature at which a solid substance melts and changes into a liquid at atmospheric pressure is called melting point. Melting point of ice is 0 degrees centigrade or 273 Kelvin. When a solid is heated sufficiently, it changes its physical state and becomes liquid. This happens because when a solid is heated, we know that in solids, particles are occupied in a fixed position. Hence, they have strong intermolecular force of attraction. When we heated it, the heat energy makes the particles vibrate more vigorously. At the melting point, the particles of solids have sufficient kinetic energy to overcome the strong force of attraction, holding them in a fixed position. And when the force of attraction decreases, the particles can move from their fixed position. Thus, it becomes liquid. Next, we are going to discuss about liquid to gas stage. Water normally exists in the liquid stage. On heating water, it ultimately starts boiling and changes rapidly into gas. The process in which a liquid substance changes into a gas rapidly on heating is called boiling or vaporization. And the boiling also takes place at fixed temperature. The temperature at which a liquid boils and changes rapidly into gas at atmospheric pressure is called boiling point of liquid. And boiling point of water is 100 degrees Celsius. When a liquid is heated, it changes its physical state and becomes gas. This happens when liquid is heated. The heat energy makes its particle move even faster. At the boiling point, the particles of liquid have sufficient kinetic energy to overcome the force of attraction holding them together and separate into individual particles. And the liquid boils to form a gas. Gas to liquid change. If we cool steam or water vapor by lowering its temperature, the process of changing gas or vapor to a liquid by cooling is called condensation. During condensation, when a gas is cooled by lowering its temperature, then its particles lose so much kinetic energy that they slow down, move closer together until they start being attracted to each other and form a liquid. And condensation is the reverse of boiling. Liquid to solid change. When water is cooled by lowering its temperature, it changes into solid ice. The process of changing a liquid into solid by cooling is called freezing. When liquid is cooled, its particles lose energy, due to which they move slowly. If the liquid is cooled enough, each particle stops moving and vibrates about a fixed position. At this stage, liquid freezes and becomes solid. Next, we are going to study about latent heat of fusion and vaporization. The heat energy which has to be supplied to change the state of a substance is called its latent heat. Latent means hidden. Let us illustrate an experiment and study what is latent heat of fusion and vaporization. Take about 150 gram of ice in a beaker and suspend a thermometer so that its bulb is in contact with the ice. Start heating the beaker on a low flame. Note the temperature when the ice starts melting. Before heating, you can observe that the temperature of the ice is less than 0 degrees centigrade. As we heat the ice, the temperature of the ice rises. After it reaches at 0 degrees centigrade, you can observe that the temperature does not rise. It remains constant. This shows that there is no rise in temperature during melting of ice. We are continuously supplying the heat. Where does heat energy go? Actually, this heat energy is used up in changing the state of solid substance by overcoming the force of attraction between its particles. When ice gets completely melted, it changes into liquid. Remember that we are continuously supplying the heat here. You can observe that the temperature of water rises gradually until 100 degrees centigrade is reached. At the temperature of 100 degrees centigrade, water boils and starts changing into steam. The heat which is going into boiling water but not increasing its temperature is the energy required to change the state of water from liquid to gas. This is known as latent heat of vaporization of water. In this case also, the heat energy supplied to boiling liquid is used up in changing the state of the liquid substance by overcoming the force of attraction between its particles. In definition, latent heat of vaporization is the amount of energy required to change 1 kilogram of a liquid into gas at atmospheric pressure at its boiling point. And latent heat of fusion is the amount of heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point. Sublimation. A change of state directly from solid to gas without changing into liquid state is called sublimation. And the direct change of gas to solid without changing into liquid is called deposition. That is the changing of a solid directly into vapor and changing of a vapor directly into solid is also called sublimation and deposition. For an example, ammonium chloride undergoes sublimation. When solid ammonium chloride is heated, it directly changes into ammonium chloride vapors. And when hot ammonium chloride vapors is cooled, it directly changes into solid ammonium chloride. Let us illustrate this example. Take some ammonium chloride in a china dish and place the china dish on a tripod stand. The china dish is covered with an inverted glass funnel. A loose cotton plug is put in the upper open end of the funnel to prevent the ammonium chloride vapors from escaping into atmosphere. The china dish is heated by using a burner. On heating, ammonium chloride changes into white vapors. These vapors rise up and get converted into solid ammonium chloride. On coming in contact with the cold and when hot ammonium chloride vapors is cooled, it directly changes into solid ammonium chloride. Ammonium chloride, iodine, camphor, naphthalene, anthracene, all these are examples for sublimation. Effect of change of pressure. Physical state of matter can also be changed by change in the pressure. When a high pressure is applied to a gas, it gets compressed into small volume, and when we also lower its temperature, it gets liquefied. So we can also say that gases can be liquefied. That means turned into liquid. Compression and cooling. This is because when pressure is applied on gas, the particles come closer and the gas changes into liquid. There is lot of space between the particles of gas. We can reduce the space between the particles of gas by enclosing it in cylinder and compressing it by using a piston. This is shown in this picture. The gas is highly compressed. The particles of get closer together and they start attracting each other sufficiently to form a liquid. And we say that gases has liquefied. When a gas is compressed too much, then heat is produced due to compression. So while applying pressure to liquefy gases, it is necessary to cool them to take away the heat produced during the compression. Cooling lowers the temperature of compressed gas and helps in liquefying. From this we can conclude that gases can be liquefied by applying pressure and lowering temperature. Have you heard of solid carbon dioxide? It is stored under high pressure. Solid carbon dioxide gets converted directly to gaseous state on decreasing of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Compressed solid carbon dioxide is called dry ice. If the pressure is reduced, it changes directly to gas without coming into liquid state.